Assalamu alaikum dear students. Our today's topic is electric field intensity on the equatorial line of dipole for class 12th. तो कल हमने डिस्कस किया था इलेक्ट्रिक फील्ड इंटेंसिटी एट ए पॉइंट ऑन द एक्सियल लाइन ऑफ डाइपोल. तो आज हम डिस्कस करेंगे इलेक्ट्रिक फील्ड इंटेंसिटी ऑन द इक्वेटोरियल लाइन ऑफ डाइपोल. So here we consider an electric dipole. We know that an electric dipole is a system of two equal and opposite charges. So we have a positive charge and negative charge here, and the two charges, positive and negative charges, they are separated by a distance, a distance. Now that distance is 2L. So here O be the center of the dipole. From the center of the dipole, the distance is L. From the center of the dipole to the negative charge distance is L, and from the center of the dipole to the positive charge distance is L. The overall length between the positive and negative charge, that is 2L, which is known as the dipole length. Here we draw an equatorial line, or we can say it's a perpendicular bisector. Now on this equatorial line we choose a point P here. We choose a point P while we want to find the field intensity, electric field intensity due to the positive charge as well as due to the negative charge. We know that the point charge creates the electric field. Similarly, this positive charge will create the electric field, negative charge will create the electric field. Both the charges, positive and negative charge, will create the electric field separately. But we have to find the field intensity at this point due to the field created by positive charge as well as the field created due to the negative charge. Now, if this positive charge will create the electric field, and that electric field is experienced by this point at this point, by this point, no, the direction of that electric field, that will be along this, and we will write it as E minus Q. So this will E plus Q. तो इसको हम टेस्ट भी कर सकते हैं यहाँ पर. अगर ये पॉजिटिव चार्ज इलेक्ट्रिक फील्ड क्रिएट कर रहा है और वो इलेक्ट्रिक फील्ड यहाँ पर महसूस हो रहा है by a small positive test charge, we can place a small positive test charge at this point, and that small positive test charge, that will experience the force of repulsion but in this direction. Similarly, this negative charge, it will also create the electric field but in this direction. We'll see here, in this direction. Because इसको भी आप टेस्ट कर सकते हैं. अगर हम यहाँ पर एक स्मॉल टेस्ट चार्ज रखेंगे, स्मॉल पॉजिटिव टेस्ट चार्ज, दैट पॉजिटिव टेस्ट चार्ज इज अट्रैक्टेड बाय दिस नेगेटिव चार्ज इन दिस डायरेक्शन. तो फिर हम इसको लिखेंगे यहाँ पर E minus Q. No, but we want to find the total electric field intensity at point P due to the positive charge as well as due to the negative charge. तो हमारे पास बहुत सारे तरीके हैं. We'll apply one of the simple method. उससे पहले we'll calculate the electric field intensity. We'll derive the electric field intensity. Already हमने निकाल कर रखा है electric field intensity due to a positive charge, due to a single positive charge. So here we'll write electric field intensity at point P due to the plus Q charge. So this will be written in this way: E plus Q, that is equal to 1 divided by 4 pi epsilon naught Q divided by the square of the distance between the two. So between the square of the distance between positive charge as well as this point P, where a small positive test charge is placed. So this will be equal to, if it is P, it will be Q, it will be R. So this is P, this is P R square. So PR square, or we can write here E plus Q is equal to 1 divided by 4 pi epsilon naught Q divided by PR square. So we have a right angle triangle here with base L and perpendicular R and hypotenuse PR. So we can calculate this PR by using the Pythagoras theorem. So this will be equal to R square plus L square raised to power 1 divided by 2. Similarly, here we will write PR, the value of PR square. Here it is PR, but we will write the value of PR square. So this will be R square plus L square So this 2 and this 2 will cancel to each other. So this is equation first. Similarly, we'll write the expression for the electric field which is created by the negative charge. Then we can write here E minus Q. E minus Q is 1 divided by 4 pi epsilon naught Q divided by, now the distance is the square of the distance, that is PQ square. PQ square. Or we can write E minus Q is equal to 1 divided by 4 pi epsilon naught Q divided by PQ square. So here, so we have right angle triangle with base L and height or altitude R and the hypotenuse, that is PQ. So this is also equal to R square plus L square raised to power 1 divided by 2. So we can write here R square plus L square. So this 2 and this 2 will cancel to each other. This 2 and both the 2's are cancelled to each other. So this will equation second. This will equation second. Now, basically we have to calculate the total field intensity at this point due to negative as well as positive charge. So हमारे पास बहुत सारे methods है. We will use one of the simple method, that's the addition of vectors. Addition of vectors. So in this case we will make a line here. In this case we will make a line here, parallel line here. So this is a line, parallel line, parallel line here. So parallel line here. So this line is parallel to this line. This line is parallel to this line. This line is parallel to this line. Now here we make angle theta here. We make angle theta here, and this is angle theta. Angle theta. Now if this length and this length that is same, so we can say if this is theta, then this will be theta, alternate angles. If this is theta and this is here, so this will be theta, the corresponding angles, because this line is parallel to this line. This line is parallel to this line. But one thing is clear here. Electric field due to positive charge, that's 1 divided by 4 pi epsilon naught Q divided by R square plus L square. Electric field due to the negative charge, that's 1 divided by 4 pi epsilon naught Q divided by R square plus L square. So both the fields, electric fields, the magnitude of both the electric fields, that is same. That is same. But only there is a difference of direction, because that is created by opposite charge. The electric field is created by opposite charge. This electric field is created by the positive charge, and this field is created by the negative charge. So they have the same magnitude. We write this magnitude by E. E. So यहाँ पर हम रखेंगे E. This is magnitude E, and this also equal to E minus Q. We will write here E. We'll write here E. Now this vector E, हमने already 11th class में पढ़ा है. This vector E can be resolved into its components. हमने 11th class में पढ़ा है resolution of a vector. Similarly, we can, जैसे आप देख रहे हैं यहाँ पर, this length is same as this length. That means they have the same magnitude. They have the same magnitude. Now, this component, this electric field E, this length E, or we can say this E, it can be resolved into its components. So one component along the direction of P, so this we write in this way. So E cos theta. So E cos theta, ये आपने already 11th class में सीखा है किस तरह आता है. Similarly, the other component of this E, that will be perpendicular to this. So this will be E sine of theta. So both the components are perpendicular to each other. आप देख रहे हैं यहाँ पर. So it's perpendicular to each other. Similarly, this length E, it can also be resolved into two components. One component along the direction of P, so this will be in this direction. We'll write it as E cos of theta. And the other component that is perpendicular to this, that is in this direction. So this will be E sine of theta. आप देख रहे हैं यहाँ पर. So E sine theta and this E sine theta, they will cancel to each other because they have the different side. They have the opposite side. So we'll write here E sine theta and E sine theta will cancel to each other. will cancel to each other. Will cancel to each other. Then the net field, the net resultant field at point P due to the negative charge as well as positive charge. So that will be equal to net field, net field, net field. That will be equal to, that is equal to E cos of theta plus E cos of theta. That is the addition of the two. That is the addition of the two. So net field. So net field at this point due to the positive charge as well as due to the negative charge. That will be the addition of these two because they have the same direction. Or we can write here E net is equal to twice E cos of theta. Twice E cos of theta. Okay. So we'll write here twice E cos of theta. No, ये E जो है ये हमने already calculate करके रखा है, so we'll calculate this cos of theta. Okay, so we'll write here, then we will write here E net is equal to twice E. What's E? That is 1 divided by 4 pi epsilon naught Q divided by R square plus L square into cos of theta. So we'll write here cos of theta. Now अब ये cos theta हम निकालेंगे, हम देखेंगे ये cos theta कहाँ से आएगा. So we have a right angle triangle with base L and hypotenuse R square plus L square raised to power 1 divided by 2 as well as the altitude as R. So we know that cos of theta that is equal to base divided by hypotenuse. We can write here cos of theta is equal to base. So we'll see what's base. So base is L divided by hypotenuse. Hypotenuse is R square plus L square raised to power 1 divided by 2. Raised to power 1 divided by 2. Then we can write net field. E net is equal to twice 2 into Q. 2 into Q whole divided by 4 pi epsilon naught into R square plus L square into cos of theta. So cos of theta is L divided by R square plus L square raised to power 1 divided by 2. 1 divided by 2, or we can write E net is equal to, so this will be 2L into Q whole divided by 4 pi epsilon naught into, so this R square plus L square raised to power 1, R square plus L square raised to power 1 divided by 2. So this will be R square plus L square raised to power 3 divided by 2. 3 divided by 2. Or, so we have a quantity here, dipole moment. So this dipole moment we represent by P, that is equal to Q into 2L here. So we have already defined dipole moment, that's the product of either charge and the separation between the two charges. So the product of either charge means that is Q, and the separation between the two charges, that is 2L. So either charge and the separation between the two charges. So that's a dipole moment. We will write here E net is equal to, so that is dipole moment P divided by 4 pi epsilon naught 4 pi epsilon naught dipole moment P 4 pi epsilon naught into R square plus L square raised power 3 divided by 2. So it will be 3 divided by 2. this is the simplest expression for the electric field intensity at point P on the equatorial line. But here we will make some approximations. If the dipole is very small, then this the distance from the center to negative distance from center to positive, so that will be very small as compared to this distance, distance from the center of the dipole to the point P. So we will neglect this distance. So we'll write here, if the dipole is short, that is 2L. This 2L is far less than R, this R, from the center of dipole to this point P. Then L square can be neglected. This can be neglected. L square can be neglected. So then we can write here, therefore E net is equal to, that will be P, dipole moment P divided by 4 pi epsilon naught into R square raised to power 3 divided by 2. So this L square can be neglected. These two which will be cancelled to each other. Then we can write net field. E net is equal to, this will be equal to 1 divided by 4 pi epsilon naught. 1 divided by 4 pi epsilon naught. 1 divided by 4 pi epsilon naught. So this will be a vector quantity here. Here it will be a vector quantity. 1 divided by 4 pi epsilon naught into P whole divided by R raised to power 3. R raised to power 3. No, this is the resultant field intensity at point P on the equatorial line of dipole, due to the positive charge as well as due to the negative charge. But what will be the direction? What will be the direction of the dipole moment? Dipole moment and the electric field. We'll see here. We already know that the direction of we know that the direction of dipole moment is from negative charge towards positive charge. So this is the dipole moment. But here the direction of the electric field, total net field, that is in this direction. So it will be around this. So this is the electric field. So we can say here the direction of the dipole moment in case of equatorial line, the direction of the dipole moment and the direction of the electric field, net field, that will be opposite to each other. So I hope you will like this video
and subscribe.